Hello, everyone. Alok Agrawal, working as an associate professor in the Department of Mechanical Engineering, Sagar Institute of Research and Technology. In this video, we'll be discussing about power transmitting turbo machine and more specifically about torque converter. So first of all, let us see what is power transmitting turbo machine. It is a power transmitting device which can transmit power from driven shaft to the driver shaft to the driven shaft with the help of a fluid. There is no mechanical linkage between the two shafts, but the power is transmitted with the help of a fluid. Here, the enthalpy of the fluid does not change and it remains constant throughout the process. What is happening here? Here, the whole system is in a rigid boundary and the working fluid is not allowed to cross the system boundary. This is very much similar to mechanical transmission device, and the only difference is that it has no positive drive since the driven and driver shaft are not mechanically coupled. So in last video, we have seen fluid coupling. In this video, we will be discussing about torque converter. So these power transmitting turbo machines are basically classified as a working principle as hydrostatic or hydrokinematics. So under hydrokinematics, we have fluid coupling and torque converter, and under hydrostatic, we have hydraulic press, hydraulic intensifier, hydraulic accumulator, hydraulic crank. There are few more machines working on the principle of hydrostatic, but we will be discussing in this four only our turbo machine. So in last video we have seen fluid coupling, which is a replacement or which is very much similar to the mechanical clutch. Now we are talking about torque converter, which is mainly as act as a torque multiplier. Means in fluid coupling, what is happening? In fluid coupling, the complete engine torque will be transmitted to the gearbox without any change on it. But torque converter, as the name suggests, it can convert or multiply the torque. Means it can change the torque and it can provide variable gear ratio. That is the uniqueness of this torque converter, which is slightly different from the fluid flywheel. So to accomplish this, we have an additional member called stator is used in the construction. Is most of the construction is similar to that of flywheel, but we have one more extra component here, convert the torque, and we called it as a stator. Its gear ratio is maximum at the time of starting because at that time the turbine shaft or the driven shaft is stationary and the driver shaft is making at its full velocity or full speed. So as the vehicle gains speed, the gear ratio decreases. So let us see how the construction of torque converter. So it mainly consists of a stator, a driving member, which is basically called impeller, a driven member, which is called turbine, and a housing on which all these three components are enclosed. This complete housing is filled with oil. Oil is used mainly because of its high lubricating power. So you can see it this figure also that first there is an impeller, which is followed by a stator. In between them, bearing is there. After stator, there is a turbine, which is a driven member, and finally the front cover of the torque converter. So this is the back cover or rear cover in which the impeller is mounted, and this is the front cover. In between these two, the main component of the torque converter are held, that is impeller, stator, and turbine. And this complete housing, when it gets closed, it is filled with oil. This is the simple construction of torque converter. The difference with flywheel is that it has one extra component, that is stator. Now let us see the working of torque converter. So this is the diagram which can be easy to understand you that here there is a drive shaft which is get driven by the impeller, and in between that there is a stator. The fluid is seen with the blue color, which is completely this complete thing is filled with this transmitting fluid. Now what is happening here, when the engine starts, the impeller starts rotating. It gets rotated, and as the speed of the engine increases, the RPM of the impeller is also increases. Once the RPM start rotated, it try to force out the oil because of high centrifugal force. So the oil will come out from the impeller with a high centrifugal force circumferential. Now this oil is going towards the turbine. Initially the turbine is in a stationary position or in rest position. Once the oil go and strike the turbine, it starts rotating. The oil will go and keep impact on the outer edge of the turbine. Okay. This flow of high energy oil from impeller to turbine tends the turbine to start rotate. So now the turbine starts rotating, and this force increases with the increase in the speed of the engine. As the engine speed increases, the impeller speed increases. As the impeller speed increases, the oil comes out from the impeller with a very high centrifugal force, and when it strikes to the turbine blades, they start rotating. The turbine blades are so designed that it will take the force and start rotating like in a same direction. Okay. So once the turbine starts rotating, the vehicle starts to move. Now this is how it works. This is our impeller. When it starts rotating by taking power from engine, the fluid will come out from the circumferential direction towards the turbine and hits the turbine outer blade with an angle in such a way that turbine also start rotating in the same direction as the hitting direction of impeller. Now what is happening here? Next, what is happening here? After the oil strikes the outer edge of the turbine blades are so designed that after striking, the oil will come out from the center and it tries to travel towards the impeller. In fluid coupling, what is there? This stator is not there. This stationary component is not there. So the fluid will start from turbine center and will strike to the impeller. When such thing happens, the fluid strikes to the impeller blade in the opposite direction, which tends to reduce the. But as there is a component called stator, which is mounted in between impeller and turbine, what is happening here? It can be seen with the red mark or red arrow that it changes the direction. It changes the direction in a favorable direction so that this fluid or oil which is coming out from center of the turbine will now hit the impeller blade in a favorable direction which multiplies the torque, which increases the speed of the impeller further and helps in increasing the torque. And that is why we called it as a torque converter. It can be seen with the animation how it works. See, from the center, this is turbine. From the center, the oil is coming, and with the help of this stator, the direction of the oil is changing. For maximum time, this stator is in a stationary position, but once the speed of the oil or the outcoming oil increases beyond certain limit, it starts rotating. But because of the blade angle, always the oil coming out from the turbine will be get directed to the outer edge of the impeller, and this is how the torque multiplication took place. See, this is the figure which need to be used in your exam. Once the stator deflects the fluid in a favorable direction, what is happening? It will multiply the torque as the engine speed increases. Thus, the maximum torque multiplication is occurring when the engine speed is high and the turbine is in a stationary position. But as the turbine speed increases, what is happening? The torque multiplication decreases. And once they will attain same speed, we call that it is in a state of equal speed. Means the turbine blade and the impeller blade both are running at a equal speed. And here the torque multiplication becomes unity. Reducing and become unity. And this is equivalent to the direct gear. So this is explained with the help of this line diagram because earlier what diagram we have seen, it is not possible to draw it on the sheet in exam. So this is the perfect diagram which can be used or which can be drawn when the question will be asked. This is turbine. It is a cut section model. In between there is a stator which is at the center of pump impeller and turbine. This arrow shows the circuit of oil which is flowing inside the torque converter. See what is happening here. Once this blue component, which is a pump, it takes the power from engine crankshaft. This is engine crankshaft, and it start rotating. Once it will start rotating, what is happening here? It will throw out the oil, and that oil will enter at the outer edge of the turbine. This oil, when hits the turbine blade at the outer edge, after that it will travel in such a direction because of the design of the turbine blade. It will make a proper path and it will come from the center of the torque converter and strikes the stator. Once it will come to the stator will just change the direction of the oil and make it to impact or make it hit the pump impeller at a favorable direction so that it will helps in increasing the speed of the and in this circuits will continue, this path will continue, and in this way the torque multiplication goes. So this is the working of torque converter. Again, see when the maximum torque multiplication took place means when the turbine is at zero speed and impeller is running at a full speed or with the speed of the engine, then what is happening? This stator, this fuel will come and hit the turbine. And now at present, it is not able to convert it into the mechanical movement. So this position is called stall. And in that position, maximum torque multiplication can take place because one component is stationary, another component is moving or rotating at a very high RPM. So this is the working of torque converter. Thank you. Thank you very much.